All right, so let's take a look at logarithmic functions, both the natural log and a log with some base. So again, like I mentioned in the exponential functions video, make sure you watch the chain rule videos first, because we'll be using some chain rule in here. Okay, so when we take the derivative of the natural log functions, we're gonna end up taking 1 over and then the inside of the natural log. So we're going to end up with a rational function when we take the derivative of the natural log. If we have some base, which isn't going to happen very often, especially with business applications and real world problems, natural log is what's happening in the natural world typically, so this is what we'll use the most. But just in case we have some base for a logarithm, you would still have the 1 over x, but in the denominator you also need to multiply by the natural log of that base right there. And same thing, like that's technically happening here, it's just that we're in base e, and if you plug in e, that just turns into a 1. So it just cancels out and leaves just 1 over x. All right, let's try this out. So we have this function. On the outside, we're taking a natural logarithm. On the inside, we have the 6x minus 2. So this is going to use the chain rule when we take the derivative. So the derivative. The outside, so that natural log is telling us to do 1 over and then our inside function. So we're going to have 1 over 6x minus 2. And then we're going to multiply this with the derivative of the 6x minus 2, so derivative of the inside function, which is just going to leave us with 6. And then we could do some simplifying here, so 6 over, I'm going to take out a common factor of 2 there, so 3x minus 1 is left. And with that, we can cancel out 6 divided by 2 is going to leave a 3, so 3 over 3x minus 1. And that would be our derivative function. All right, with this one, g of x, we have a numerator and denominator, so we're going to start with the quotient rule. Quotient rule, okay. So, taking the derivative, we're going to start with low d high, so x to the 4th times the derivative of natural log of 2x. Minus high d low, so natural log of 2x, times the derivative of x to the 4th, all over low low, which is going to be x to the 4th squared. All right, so we're going to have x to the 4th times, so the derivative of natural log of 2x, this is going to use chain rule because we have this outside function that's the natural log. Inside function is 2x. So taking the derivative of the outside tells us to go 1 over and then whatever's inside the parentheses. So 1 over 2x. And then we're going to multiply by the derivative of that inside function, so derivative of 2x, which is 2. Then we're going to go minus natural log of 2x times the derivative of x to the 4th, which is a 4x cubed, all over, so x to the 4th squared, do 4 times 2, and that's x to the 8th. And yeah, let's keep going horizontally here. So, simplifying this right here. In the numerator, we have x to the 4th. We have a 2, and an x is going to cancel out, so actually let's go ahead and take care of that. We're going to be left with x cubed there, and then actually the 2's cancel out as well, so really all of that simplifies down to an x cubed, which is very nice. And then minus natural log of 2x times 4x cubed, that's all separated. What I can see is this nice common factor of x cubed, so let's go ahead and factor out x cubed, which has so much canceled out there, so we're just going to be left with a 1 in that first term, and then minus, and we'll have a 4 times natural log of 2x left over in that second term. all over x to the 8th. And we're going to get a nice cancellation here. So we can cancel out 3 of these x's. So there's going to be 5 left over in that denominator. So this derivative is, in the numerator, we're going to have a 1 minus 4 times natural log of 2x over x to the 5th. And we're done. All right, a few more examples here. Again, if you're getting the hang of this, especially as we're practicing these rules more and more, feel free to pause the video and try these out for yourselves so you can compare and contrast your answers. All right, this one's going to use the product rule since we are multiplying. So I'm just going to make a note of that this is the product rule. So h prime of x is equal to, we're going to go first times the derivative of the second plus second times derivative of the first. Okay, so keep that e to the x. Derivative of natural log of x is just 1 over x. Then we're going to go plus natural log of x times the derivative of e to the x, which is just e to the x. No chain rule here since we weren't doing anything special in the exponent or inside the logarithm. So this right here is just e to the x over x plus, let's put the e to the x first, e to the x times natural log of x. And that's done. All right, a scenario where we have a different logarithmic base. So log base 4 of t squared minus 9t. So notice that this is going to use the chain rule. The outside we have this logarithm, inside we have this t squared minus 9t. So taking the derivative, using the chain rule, we're going to take the derivative of this logarithm base 4. So what it tells me to move our value, move the inside function to the denominator, but also multiply by the natural log of that base. So we're going to have natural log of 4 times our function t squared minus 9t. And then we're going to multiply this by the derivative of t squared minus 9t. So, and that's going to be up in the numerator. So derivative of t squared minus 9t is a 2t minus 9. And this is going to be over, we can just leave it like that. We could factor out a t. It's not really going to do anything here. This is just going to be natural log of 4 times t squared minus 9t. So what I was kind of mumbling to myself there is there's a common factor of t that we could factor out, but it's not going to be able to cancel out with anything because we would have to see this whole 2t minus 9 as an expression in order to cancel out with anything. So we're stuck like that. All right, yeah, one more example here. Natural log of t squared minus 5 over t. So we have on the outside of everything, we're taking this natural log, and then inside we actually have a quotient. So taking the derivative, we're going to start with the chain rule. So the chain rule says to take 1 over, and then we're going to have our inside function, which is this t squared minus 5 over t. And then we're going to multiply by the derivative of that inside function. All right, some things we can do to simplify. For this first piece, we end up with a complex number because we have a fraction within a fraction. What we can do is just moving things around, but it's like we're multiplying the denominator and numerator by that value of t, so that down there it cancels out, and then we just end up with t in the numerator. So what we can do is that step so that we don't have a complex fraction anymore. So t over t squared minus 5 is the same thing. And then here we are going to have the quotient rule. So taking the derivative, we are going to have low d high. So t times the derivative of t squared minus 5. You know what? These are somewhat simple values. I'm going to go ahead and just start taking the derivatives. So derivative of t squared minus 5 is just 2t. And then we're going to have minus, what did I do? Low d high, so minus high d low. So we're going to have t squared minus 5 times derivative of t, which is just going to be a 1. So really we have this multiplication of 1 here, which isn't doing anything, all over low, which is t squared. All right, that negative needs to distribute in, so we're going to have negative t squared plus 5. And let's see what we can simplify. So let's keep these separated for now. So we're going to have t over t squared minus 5 times, and let's see, this is a 2t squared, but then we're subtracting t squared. So really we just have 1t squared plus 5 over t squared. Okay. Trying to look for some things that will cancel. But, so in terms of canceling, we cannot cancel, oh, I probably should have said this so much earlier, but hopefully you've been noticing the theme that we cannot cancel across addition, subtraction. So like I can't cancel those two values, but I can cancel across multiplication. So I'm going to do one step here of showing how this is t times t squared plus 5. And there isn't any factoring to do here. This isn't a difference of squares or anything. And then the denominator, we have this t squared times t squared minus 5. And keeping it in this factored form, what I'm going to do is I can see I can cancel out a t value. But I can't cancel out any of these because up here's addition and this is subtraction. So those are stuck. But t and t squared, I can cancel, so I just have 1t left over in the denominator. So this is going to simplify to a t squared plus 5 over, then we could distribute it in now that we've simplified. Let's go t cubed minus 5t, and that would be done. All right, so there's our logarithm rules. Most often we'll be dealing with that natural log, but we do need to be careful if we have a log of a different base.